All right. Happy New Year, everybody. Welcome to Pre-Calculus. I am Resh Mahaber, and we will go ahead and take you on your little journey. But before we get started on our journey, let's do a quick review for guys who are not in the course. For who are in the course, this is section 1.5. And in section 1.5, we do a complete review of equations. Now, equations in general are a key component to this course. So if you can't solve them, it becomes very, very incapacitating. So we got to make sure we're good. So this is just review of equations, okay, and how to solve them, more importantly, okay. So if you remember in whatever class you had previous to this, they had all different types of equations. When I mean all different types, I mean we had rational equations. I mean equations with fractions in them. They looked a little bit like this guy. Minus 1 plus 2 over x plus 1. And that guy was equal to 35 over x squared plus, minus 1. Sorry, guys. And of course, your instructions is solve. Okay. So with this being said, how do we deal with this? Well, same thing like any other time. You look at your denominators and you say, what is the least common denominator? Well, that's going to require you to factor this item right here because this is a polynomial of degree 2. Okay. So this factor of x minus 1 and x plus 1, that's okay, but what is that thing? Now, if you recall your skills from whatever course you came from, or one that you just tested in here, you should know that this is called the difference of squares. It's a really cool factoring trick from guessing and checking. So it gives you that. So you can kind of see that this guy is missing, this guy right here is missing an x minus 1. You can see this guy here is missing an x plus 1. And this guy has the whole shebang. So the LCD is x minus 1, x plus 1. Now, what are we going to do with this? Well, we're going to clear the fractions out. We can't solve for x in the denominator. But remember, this is the big key here. The reason we can clear the fractions out is because of this thing right here. It's an equation, meaning that it's a scale. That means whatever's on the left side and whatever's on the right side is supposed to be balanced. So you could do whatever you want as long as you do it to both sides. So since I have this fraction, that's the first guy, plus this fraction is the second guy, and then this fraction over here, that's one guy on the right, every single guy is going to need to be distributed a LCD of x minus 1, x plus 1. So it should look like this. So I'm not going to do any mathematics. I just want to make sure you see the distribution here. This thing is going to have to be multiplied by the first fraction. Then it's going to have to be multiplied by the second fraction. Now, some people are like, well, yeah, I can kind of see and do this in my head. If you can, then great. That means you're exactly where you need to be. But if you can't, that's why we show work. It's kind of like playing a video game. You ever try to play a video game and never have the ability to save, like how the original Mario Brothers were? For you guys who have that point of reference, it is exhausting. That means if you messed up once, you had to start back at the beginning. You never want to be in that predicament. That is why we show work, and that is why we show multiple steps. So now, this is the same equation, and I'm just putting in these little components here. Oops, wrong thing. Whoops, did it again. I'm seeming to having some technical difficulties. So if you notice, these things are things that I put in. Now if you notice, this guy right here and this guy right here, they're going to factor out. They're going to give you a 1. This guy right here and this guy right here, that will factor out. And this entire blob and this entire blob will factor out. So what are you left with? Well, you are left with this beautiful thing. It's going to be 4, and the x plus 1 is on the outside. Bring down your plus sign. X minus 1 times 2. And then it's going to be 35. Notice I didn't even do any mathematics. It was just a lot of rewriting. But what it does is it sets you up for great success. And that's kind of the idea. You never want to be in a predicament where you're caught with your pants down, figuratively speaking. All right. So now what do you do here? Well, now we just got to grind through the mechanics. So let's see. This gives me 4x plus 4. Plus 2x minus 2 equals 35. And I always say be careful here. It's so easy to make a really rinky-dink mistake. So when we simplify this down, this will give us 6x plus 2 equals 35. Subtract it over, we end up getting, and since I'm running out of space, I'll put it right here, 6x equals 33. Subtracting over that 2, x equals 33 over 6. And yes, if you leave it like this in my class, I will knock points off because you need to simplify. What does that mean? 3 goes into the top and the bottom. So that means this is 3 times 11, 3 times 2. That factors means the answer is 11 over 2. And yes, this guy, if I did everything correct, should work. Now here's the question. What two guys should not work? If I were to end up with an answer here, what two answers, if I got them, I know immediately I need to throw them out? Well, if you're thinking correctly, you should think the numbers 1 or -1. And why? Because it makes my denominator 0. Okay, anything that makes your denominator 0 you can't have. So you must check everything that you know. Okay, so this is the first kind of equation that we did, that we talked about, or we're going to need to do in order to operate in this class. Okay, here's another guy. Okay, now this is what we like to call a rational equation. And why is it rational? Because rational means ratio, which means fraction. Okay, so hence why we have fractions inside the equation. Let's talk about another type of equation. Okay, this one is called a polynomial, and you guys already know about polynomial equations. Okay, equations. This is probably the biggest one that we're going to use this semester. So here's an example. This guy is what we call degree 2, or quadratic. Quadratics are a big guy, so check out this. 4x plus 3 equals 0. And then you guys should already know this by now. To solve anything that's like this, you have to factor. So again, that's going to be factor into this times this. So if your factoring skills aren't tight, you might want to consider retaking the course previous to make sure they are tight, because at this stage in the game, it's got to be almost instantaneous. So that factors into this. And yes, if you're not sure, go to the side and check it or do it mentally. So x equals -3 and x equals -1. And yes, you can go back in and check it. Okay, so this is called factoring 0. And what does that mean is that when you have something equal to 0, that means if you have something times something equal to 0, that means either the first guy is 0 or the second guy is 0. So that means what are the numbers that make those first and second guys 0? Boom. Hence your answer should be -3 and -1. Now, will everything factor for degree 2? True story, no, it will not. Okay, that's why you need this handy dandy formula. So for degree 2s, sometimes, so let's say it was this guy. Now let me get some new space. Erase. Let's say it was this guy. X squared plus 4x, but instead of plus 3 this time, it's -3. It's very tempting to think it factors. It does not, though, however, okay? So what do we need? Well, to solve, we need the quadratic formula. Okay, and remember what that is, and you should be saying to yourself, and a lot of people like to say, oh, it's -b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient on the squared item, b is the coefficient on the x item, and c is just the constant. Where this is the case, okay, you're missing something very, very important here. This is not the formula. Okay, this formula is the answers to this. So x equals those things, and that's very, very important that you know that you're already going for the solutions. Now note, it only works on degree 2s, not degree 3s, not degree 4. So if you have some method of factoring this down, your degree 2s into a degree 2, then you're ready to rock and roll. So for example, let's take a look at this guy. Okay, x cubed plus 4x squared equals 3x. All right, so you look at this guy and you say, okay, well, how do I deal with this? And obviously your instructions are to solve. So it's degree 3, so you should end up with 3 solutions. So first things first, you need to get 0 on your right side. You get x cubed plus 4x squared minus 3x equals 0. Then you say, oh, I could factor it. Beautiful. And you get here. And then you say, oops, well, does this thing factor? Well, this guy is easy. This is just going to give you x equals 0. Okay, that's one solution. Okay, but what does this give you? Well, you got a quadratic formula. So you go to the side and you say, okay, well, a is 1, b is 4, and c is -3. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Ugh. Now, guys, me personally, I do not like using the quadratic formula just because it is so icky. I learned something different when I was going through school. I didn't learn quadratic formula. They taught me to complete the square, and that was the method of isolating within a quadratic. In class, I'll show you guys that. It's actually quite nifty. Once I started doing that, I stopped using quadratic formula. But anywho, let's simplify this down. It gives us 16 plus 12 all over 2 equals negative 4 plus or minus the square root of, what is that, 28? And in your mind, you say, oh, this simplifies. Yes, it does. Plus or minus 2 square roots of 7. Why 2 square roots of 7? Well, 28 rooted is the same thing as square root of 4 times 7. Oops, you can't see that, can you? 4 times 7, which is the same thing as square root of 4 times square root of 7, which is the same as 2 root 7. Okay, all over 2. And notice the 2's factor into it. So it's negative 4 over 2 plus or minus 2 root 7 over 2. And then it divides in. It divides in. I'm going to put the answer to that right here. That'll be negative 2 plus and minus root 7 over 2. So your answers is going to be these two guys for x and this one guy for x. Isn't that easy? Okay, so yes, this class is very, very involved and requires a lot of good algebra, so make sure your skills are up to par. Okay, let's talk about, we're already 10 minutes in, we probably got maybe 2 or 3 more equations to talk about, and then we'll be ready to move on with the next big thing in the book, which is word problems. Alright, so let's clean our slate real quick. So that's polynomial equations. Let's talk about one of my favorites. This is what I like to call the undercover equation. This is what the guys that were quadratic, they are quadratic in nature, but they are quadratic-like. Okay, that means they're not exactly quadratic. Here's an example for you. Okay, x to the 4th minus 5x squared plus 4 equals 0. Okay, what degree is this? You should already know in your head it says degree 4. Now it could be degree whatever, it could be non-degree, it could be something ickier, right? But it's degree 4, which means it's not quadratic. So what are they meaning it's quadratic-like? Well, right now degree 4s, we don't know how to factor them, okay? But maybe it's quadratic-like. So what makes something a quadratic? Well, if you remember a quadratic, here's general form, right? One guy is the square of the other guy. So notice you got an x here and then an x squared. So the idea is your variable stuff, one guy should be the square of the other one. Now, will it always be obvious? Not really, but your skill set should put you into place, okay? So it all comes down to choosing a dummy variable, which we will call u. So we need to choose u to be something to reduce this into a degree 2. So what will u be? Well, the idea is one's the square of the other one, so pick one, okay? So let's say you pick x to the 4th. If this is your choice, here's your check for your choice. I'm going to square my choice. If this is true, then anybody know what we do when we have an exponent to an exponent? You should say multiply, okay? That means that if this is my u, then u squared would be x to the 8th. Is there x to the 8th up here? No. Bad u. It's a bad choice of u, okay? So let's try the other one. Let u equal x squared. That where u squared is equal to my choice squared. This is my check, equals x to the 4th. Is there x to the 4th up here? Bingo. So that means anywhere I see x to the 4th, I should put a u squared. Anywhere I see x squared, I should put a u. Okay, so this turns this equation up here into u squared minus 5u plus 4 equals 0. And good news, now it is exactly a degree 2, and you can use all the cool things you know about degree 2s. You could factor them, you can quadratic formula them. You better pray you don't have to quadratic these guys because this gets really icky. But if you do, you're just going to have to grind through the algebra. Okay, so it's u minus 4, u minus 1, that factors equals 0. This ends up being u equals 4, u equals 1. Right, and then we're not done because we're not solving for u. We created u, but what did we choose u to be? X squared. So now we're going to resubstitute it in and then solve. Okay, so when something's degree 2 and you square root it, here's the big thing. Don't forget the plus or minus. Okay, so this is plus or minus 2. This is going to be plus or minus 1, and you end up having 4 solutions. Should you check them all? Absolutely, because sometimes they will not work. In this case, they do, and just in essence, in time of the video, I'm not going to check them right now. You could do that on your own. Okay, quadratic-like solution, and check this out. 4 solutions, degree 4. Isn't that beautiful? Okay, now you're not guaranteed to get same solutions, meaning you're not guaranteed to get different solutions. Like all of these answers could have been they could have all been the same number. You never know, okay? But bottom line is you should end up getting 4. So this is another guy, quadratic-like solutions. And there's many different ways you can choose u, so I'm not going to go through all the different facets of the equation. You just got to be good to at this point where you've developed an intuition. All right, let's erase this. Here's another guy I want to talk about. This guy is called radical. equations. Okay, and here's an example for you. The square root of 2x minus 3 plus x equals 3. Now, the idea is this, is that we have to undo this radical. Now, what undoes a square root or cube root or fourth root? You should say to yourself, it's using the exponent. The exponent undoes it. So first thing you got to do is isolate for the root. For root. Okay, so first thing I'm going to subtract that x over, which gives me this. Now, how do I undo the square root? Square it, right? So I'm going to square both sides. Now what happens here is that undoes it. This gives you this squared. Now if you tell me this is 9 minus x squared, in my class that's minus 10, game over, you lose. Because at this stage in the game you should know that exponents do not distribute over addition. Okay, you must distribute this out as 9 minus 6x plus x squared. Alright, now let's rock and roll. I'm going to push everything over here because I want to keep the highest degree positive. It makes it easier to factor. I'm going to write that first, and it's a negative x, and try to give me negative 8x. And I'm going to add this over, which gives me a plus 12. Did I do this correctly? It looks like I did. Double check. I'm a big proprietor of double checking because if you blow a problem and you wonder why it didn't work out well, chances are it's all because your algebra was just a tad bit off. Alright, that seems like that's it. Alright, so now, does this factor? This is the question. Well, yes, I think so. Doesn't 12 factor into 6 and 2? Wasn't that nice? So x equals 6 and x equals 2. Right? Are we done? No. We must check. The left side must equal the right side. So check this out. If x equals 6, here's my check. Then we get the square root of 2 times 6 minus 3 plus 6. Now, if you were really paying attention to the game, this should have been enough to kill it. Why? Because if you got 6 and you're trying to get 3, right? If you add something to 6, it's not, and square root stuff's got to be positive, it's not going to shrink down. Okay, so you could have tossed out 6 immediately. But if you didn't get that, you should go through and work it out. It gives you 12 minus 3 plus 6, 9 plus 6, 3 plus 6, which is 9. But that's not equal to 3. No good. 6 does not work. Do the same thing with 2. Square root of 2 times 2 minus 3 plus 2 equals 3, hopefully. And this gives me square root of 4 minus 3 is 1 plus 2 equals 3. And that's 1 plus 2 equals 3. It does. Bingo. So it's just 2. Easy peasy. And I don't care if there was 30 roots, I would isolate and square it every single time until I got what I needed. Okay, which is all the roots are gone, and it turns into a polynomial that I can deal with. Very cool, because once it gets to that polynomial, it's factor city, and I can do everything I want to do. Okay, and then now let's talk about one more kind of equation that we've noticed, and that's this guy. He's a very cute equation. He's called the absolute value equation. Okay, depending on who your instructor was, they taught this very differently. So here's an example for you. And I'm going to just break it down in layman's terms. Anytime you deal with an absolute value, you got to isolate for it first. Absolute value is not like a parentheses. He's more like a, I guess a technical term is metric, but he's not a parentheses. He's something you have to think about. It's kind of like you have to think about what makes him work before you can even get started. So first thing you got to do is isolate. And you'll notice this, anytime we have weird stuff in math, we always isolate for the weird thing. So this is for the absolute value in this case. We call this doing an analysis of the problem. So I'm going to subtract the 3 off. My absolute value is still negative. Okay, it gives me negative 7. And I'm going to multiply by a negative, which gives me positive 7. Now, check peep game, everybody. This is where stuff gets really, really good. Okay, so I need you to think to yourself, what two numbers have an absolute value of 7. Okay, in my class we call this the distance away from 0, where there are 2 numbers who have this distance. Okay, so let me make sure I draw a picture for you. Okay, here's 0. If I take 7 steps to the right, 7 steps to the right, where do I land? Correct, right? So the number 7. Where else, if I take 7 steps to the left, where do I land? Negative 7. But note, this 7 right here is not this 7. Right there. Let's change colors just so I can make it theatrical. This 7, which I'll make red for your viewing pleasure, is this 7. The steps. And this 7. The steps. So for these two guys, negative 7 and 7, right? Those two guys, that's what this crap can possibly be in here. Either the stuff inside there can be -7 or he can be 7. So now the question you need to answer is, when is the stuff on the inside equal to that, or when is it equal to this? Now you just got to solve. Okay, so you end up getting 2x equals, what is that? Add that over, you get -6, x equals -3. And then 2x equals 8, x equals 4. And if you plug it in and check it, you'll see that they both work. I'm not going to go through the details, but I'm sure you guys can do that. Okay, so that is all the equations that you will need this semester to know how to solve, just getting into it. We'll get into more nitty-gritty as time goes on. But remember, in order to do anything or go anywhere, well, and just in general, in order to go somewhere you haven't been, you have to be willing to do something you haven't done. So guys, get uncomfortable, make sure you grind, make sure you are getting to a place where you're starting to discover what you don't